Thanks, everyone, for joining us today at our inaugural Analyst Day. We've got some great content for you, but before we get into our amazing content, I got to go through some formalities. So let me read some forward-looking statements, and then we'll get to it. Thank you for joining us today at the Plus Analyst Day. The webcast of this event will be available for replay at plus.ai-investors, where you'll also be able to find a copy of the investor presentation. Please note that this afternoon's webcast contains forward-looking statements regarding future events and the future performance of PlusAI and Churchill Capital 9. These forward-looking statements are based upon information available to PlusAI and Churchill today and reflect the current views and expectations of PlusAI and Churchill Capital Corp 9. Actual results could differ materially from those contemplated by these forward-looking statements, including but not limited to timing of development milestones, potential future customers and revenue, competitive industry outlook, and the timing and completion of our business combination. Please refer to the presentation accompanying this webcast, as well as filings and potential filings by PlusAI, Churchill, or the combined company, resulting from the proposed transaction with the SEC, including under the heading Risk Factors. Now, let's move to the agenda. So today we have some great speakers. We have a co-founder and CEO, David Liu. We have our chief architect and co-founder, Tim Daly. We have Sean Kerrigan, one of our co-founders and chief operating officer. And the last person from Plus is Steve Spinner, our chief financial officer. We're also really excited to have Tobias Glitterstam from International TRATON. And here's our agenda. And we'll start off with David giving an overview, and then we have a lot of exciting segments after that. Also, I promised to get everyone out of here on time for earnings after market, so we'll be done about 3:15. With that, let me hand it over to David.
Thank you, Derek. Good afternoon, everyone. Welcome to PlusAI's Analyst Day. We have an exciting day agenda for you. PlusAI was founded in 2016 with a clear mission to apply self-driving technology to transform the transportation industry, to make transportation safer, more efficient, and more sustainable. I feel incredibly fortunate to have an opportunity to work with a team and lead a company to have a major sustainable impact globally. Just as modern-day factories transform how we make things, autonomous driving is going to transform how we move things. And trucking is the beginning of that transformation. Over the past several years, we have built a technology platform that's proven to work in real-world deployment. We have built an AI-native virtual driver platform called SuperDrive that can power heavy trucks to drive on public roads without a driver in the cabin. Many leading global OEMs have selected PlusAI to deep integration at the factory level across their platforms. Our technology leadership is proven by the fact that they went through this whole selection process and rely on us on the future of their businesses. Our technology leadership is rooted in a simple belief that speed of innovation delivers performance. So we combine an AI-native, large neural network-based model that delivers driving intelligence that is data-driven to provide speed on innovation. But we also have a guardrail system that's explicitly rule-based and a redundancy system to provide a level of safety guarantee. This hybrid approach allows us to move fast without ever compromising on safety. With the leading technology, we've also established the right partnerships to deploy autonomy at scale. We work with many of the leading global OEMs to deploy our technology at scale. TRATON Group, which is Volkswagen's commercial trucking group, including brands like International Motors, Scania, and MAN, as well as Iveco Group and Hyundai Commercial Vehicle Group, have all selected Plus as their autonomy provider for their products. And today, we're very excited to also have Tobias Glitterstam, who's the Chief Strategy and Transformation Officer at International Motors, to join us to discuss how they're thinking about autonomous trucking and their roadmap for global deployment. At the core of our business is a clear strategy. PlusAI is the technology enabler. We are here to enable and transform the industry. We provide the autonomy software to truck OEMs to integrate our technology at factory. OEMs install our virtual driver on their new trucks that are built in the factory. They sell these autonomy-enabled trucks to fleets. As these trucks are utilized by the fleets, we generate per mile SaaS-like business revenue with a SaaS business model. This model aligns interests across the ecosystem, across the fleets, the OEMs, as well as PlusAI. And that's what's allowed the autonomy to really be deployed at scale. We are at a clear inflection point. 2025 was a pivotal year for us. We completed driver out testing. We materially improved our performance metric. We launched commercial trials with our OEM partners, and we're seeing great demand from many of the major fleets. They're eager to participate in our commercial trials. Autonomous trucking is no longer theoretical. It is here today. It's becoming operational. 2026 will be an acceleration year for us. We're expanding our commercial trials. We're continuing to improve performance metric with a target to close safety cases for Texas by the end of the year. And this year will be about moving from proof to repeatability, from pilots to readiness for scale deployment. All the pieces are now in place for successful commercial launch in 2027. We have the technology. Our performance metric is closing to scaled launch. We've secured distribution channel with our OEM partnerships. We're seeing strong demand from the fleets, and we have built a capital-efficient model for scale. All that's left for us to do is execution, and we're extremely excited about the future of our business. With that, I'd like to invite Tobias Glitterstam to join me for a fireside chat, where we will discuss International Motors' plan for developing and deploying autonomous trucks. Thank you.
These are for us?
Yes. All right, let me first introduce Tobias. Tobias Glitterstam is the Chief Strategy and Transformation Officer at International Motors. He's responsible for the commercialization of autonomous vehicles in North America on behalf of the TRATON Group, as a member of the group's Autonomous Steering Committee. So Tobias, it's great to have you here today, joining me in this important event. Perhaps we can start by having you tell the audience what your role is as the Chief Strategy and Transformation Officer at International Motors.
I'd love to. First of all, hello everyone, and thanks for attending. Great pleasure to be here alongside our very important partner, PlusAI, today. So, two parts of that title: strategy and transformation. Strategy normally self-explanatory. Transformation, the more important part, because I share the view that this is about execution. Transformation is about keeping a close eye on the very rapid development in the industry, and of course equipping us as International Motors being the TRATON go-to-market organization into North America to equip us for that future. Some of those most important trends, of course, include autonomous, and for that reason I oversee what we do within autonomous. Many of these new trends also involve partnerships, and partnerships with that is part of my responsibility, and PlusAI as such a very important partner. Electrification, another area I spent time, would love to see the same momentum on electrification as autonomous. Matter of fact, autonomous is much more in demand of our customers currently. Broader topics of digitalization and AI, of course, also part of my scope.
Great. Tobias, can you talk about how important autonomy is in International Motors, business strategy, as you're kind of setting the strategy for the group?
I'd love to. So, rather than the importance for International Motors, I think it's all that we do starts with our customer. And I have a friend in commercial that used to say, what interests our customer fascinates us. And autonomous is one of those topics that is very high up on the list of priorities for our customers. So that's really the starting point. And we want to be one of the leading players as we are in conventional transportation and providing those offerings. We see ourselves as a leader in providing autonomous solutions as well. So I think the question maybe is rather, why is this so important for our customers? And I think it starts with it's well known that we are serving some of the largest fleets in North America. So the Penske, the Ryder, the Schneider, the JB Hunt, the Werner, those are large customers of ours. And I think it starts with actually efficiency and TCO. So if you think about it, if you look at the total economy of freight, the driver is always more than a third of the total cost, sometimes up to half of the total cost. So, of course, if you can address that cost base, that can finance some of the advanced software required, that can easily finance some of the additional sensors and equipment you need on your trucks, and some of the complexities you need to support in that operation of what we call hybrid fleets, both conventional and autonomous. So efficiency, TCO. But I think as important, reliability of their consolidated fleets. Not only is it hard to recruit drivers, it's hard to actually keep drivers as well. It's well known that we have a substantial shortage of drivers in the industry. So, and also the demographics doesn't speak it doesn't favor us if you would look at the typical profile of today's drivers. So the idea of being able to introduce an autonomous super driver is very attractive. To have a driver that always show up in the morning, that never call in sick, that is always willing to work the extra hours. If we can help make that happen and provide those solutions, that's very, very attractive. And thirdly, safety. Of course, on the one hand, safety safety is a concern with autonomous. At first, it can come across as terrifying to see these large size trucks driving down the freeways in full speed without a driver. At the same time, human error is part of almost every accident currently. And to have a super driver, an autonomous driver that can learn not only from own mistakes, but from all other drivers eventually mistakes is something very attractive, and that should play into a longer-term safety agenda as well.
Yeah. So clearly, autonomy is the important part of your strategy, right? At international motor level, at the TRATON as a group level. And we know, TRATON Group has been working on autonomous driving technology for many years. But when your team was evaluating partners, technology partners on enabling autonomous driving for on-highway, for public road solutions, what were the criteria? And why did PlusAI stand out? And what sold you ultimately on choosing PlusAI as your core partner?
Yeah, so first of all, it was not only an evaluation of the different PlusAI companies or players, credible players in this space, and there are not too many of them, I can tell you. We have tried hard ourselves as well. We know how hard it is to develop these autonomous software. I think the starting point will always be the technology. So it's a lot of time engineer to engineer, R&D organization to R&D organization. So clearly the majority of the time, let's say the first year, because it was a long process to evaluate technology, skills, the strength of the engineering team. That's really the starting point, and we came to conclusion that there is no one stronger than Plus when it comes to the core of the actual solution and the ability to keep developing that with a different technology generation. So I think that's the starting point. Otherwise, we would have not moved from that point. But all that time that we spent together between our teams also led to the more informal criteria, and that's much more around the culture, because we've been at this before with partners in autonomous area and in other areas, and we were looking for a partner that are like-minded in terms of taking a very longer-term approach to it. We're a very engineering-driven organization ourselves. So for us, it's very important with the collaboration with the respective, between the respective engineering teams. The software will never work without our software and vice versa. And the integration is really what can be the differentiation. So that collaboration, the transparency, the openness. So while on the one hand we need, as in all partnerships, clear roles and responsibilities, we need a culture and approach of one team. So that was very, very important to it, and that's proven to be right in these initial years. If there is one third area, and there are a few others, but the third area I'd like to speak to, and where I've been very involved myself, is the simplicity in the business model. Both the simplicity in the business model between us, so that we would always have the shared intent and shared interest to take this into commercialization and start to ramp it. So the way the partnership is set up between us, if we succeed with this, it will truly turn into a win-win. But also we hear from our customers that they put a lot of trust in us. They want to continue buy the solution from us, and they want very clear liability and responsibility, and to be able, alongside the partnership with Plus, to stand up in front of the customer and take responsibility for the full solution. I think the way we have set that up is absolutely in the best place to scale in the industry. The technology is so revolutionary, so disruptive itself, we don't need to overcomplicate the business model as well. And there will continue to be value add by all the parties in the value chain as today going forward as well. So I think the tech starts with technology, the cultural fit and the way we work together, and we just have more and more proof points of that, but also the way we've been able to set up the business model to best serve the customers.
Appreciate that. When we say that we measure our success based on our customer success, we really mean that. So thank you. Thank you for your partnership.
And I hope you don't think of us, but our shared customers.
Yes. So we announced the partnership back in early 2024 officially. So perhaps you can tell us, from your vantage point of view, what are the progresses we made together so far in terms of developing the technology, developing the product, and commercially together?
First of all, it feels like much longer than 2 years, because if I think about what we did see then, and we were already at the stage of like conceptual prototypes and retrofits and showing indications of how
5 years together, if you count all that.
Yeah. But in these 2 years, we have really been going from that development and prototyping into real piloting and real commercial fleet trials at this point. So you can speak better to how the entire feature development, how we make these vehicles more and more capable. But at the same time, we are now on the second generation of hardware and about to develop the fully autonomous ready vehicle in parallel. So it's about bringing these feature sets, this software, onto the hardware platforms. And the big moment last year was that we jointly considered that ready and met all the validation points to take that into commercial fleet trials. That means that we now operate real freight for one of those large fleet customers that I mentioned of before. More to follow in the spring on that. But we operate in autonomous mode, still with a safety driver that's not subject to outstanding features on the Plus software as much as it is to have a fully redundant vehicle. You need both the software driver and the fully redundant hardware, bringing the two of them together. And then the whole operational support structure to deploy this with customer. But we operate every day from Laredo, from the border from Mexico, to one of the large automotive factories near Dallas. So that I-35 route, we do transport 5 days per week. The absolute majority of it in autonomous mode. And of course, that validates the product itself, but it also pressure tests all the autonomous structure. For us as an OEM, this is also a big opportunity to bring value add to customers in terms of services. So if there is a tradition in North America to have fairly reactive repair, etc., that cannot work when you go autonomous. We need to secure and be accountable for the uptime of these vehicles. They cannot stop on the freeway. So that whole daily operation and control tower monitoring all the vehicles on the road, etc., setting up that structure, all the dispatch routines, all the additional complexities by operating as if we didn't have a driver when you show up at the customer site. So it's also very important in terms of enabling that autonomous operation alongside our customers beyond the technology itself.
So there's a general market kind of consensus or in terms of timeline roadmap that driverless trucks with redundant chassis will start becoming available commercially in 2027. How does that timeline fit with your internal plans, and what's left to be done before that commercial launch?
So, I say we're generally aligned with that timeline. There is no question about the macro development and the power of the force of autonomy in our industry, and the power of that business case and the maturity of the core technology. Then I must say we're actually less concerned if this then go fully driver out in Q2 of 2027 or Q1 of 2028. This is a starting point of a trend that is unstoppable. So when we reach that inflection point, it will naturally start scale. There is one thing we will never compromise on, and that is safety. For that reason, we don't commit to an exact timeline. We would never compromise on the safety aspect of it. And also, if we have been used historically to sell trucks to our customers, the first time these fleets start adopt autonomy, you really have to consider it a joint project. It's a three-party project between these large fleets, us, and alongside Plus. So for that reason, you may have to allow a little bit of time, but that we will start to see driverless commercial transportation in 2027, no question about that, and that we think of ourselves as the combination as one of the leaders in that is also true. So yeah, broadly aligns.
Yeah, we totally agree with you. We want to move fast, but without ever compromising on safety. So I think culture-wise, we're totally aligned on that. So TRATON Group and PlusAI have recently announced the expansion of our global partnership to accelerate the development and commercialization of autonomous trucks. How does the expanded partnership fit into your strategy?
So I think first of all, we're very pleased about that extension, that deepening of our partnership. We already had a very strong mutual commitment to go and take on this market, the fully autonomous commercial transportation in North America and Europe. This is a way to accelerate that to start with. That is the top priority. But it's also, I think, a recognition and reconfirmation of the progress we've made to date in these 2 years that we are interested in to doubling down from a commercial and strategic standpoint. From an engineering standpoint, in the collaboration between our respective teams, it's become clear that you are building a lot of strong assets and capabilities that can be applied in other parts of our vehicle portfolio as well to integrate certain elements of your safety solution, as an example, in our safety offering to our customers, in our software-defined vehicle platforms. So it's just opened up to leverage some of the leading technology you develop on more broad base, not only for the L4 driver out offering, even if the acceleration of that remains the key priority. So very pleased to see again, and it's really comes bottom up from our respective engineering teams identifying those opportunities, and then we get to do the easy part to find a good structure of shaping that in an extended partnership. So very, very pleased and excited about that.
Last question. What does a successful long-term partnership between International Motors and TRATON and PlusAI look like in your view?
So I think I already... And it's always easy to say that you need to have this mechanism for a win-win partnership. I think in this case, we need to pursue the win-win-win and include our customers in the mix as well. We want to become the leading provider of autonomous solution to some of those largest fleets to start with, and then we are sure that others will follow. That win-win-win will have to include a sharing of that that cost upside we can create by having the autonomous driver. So there should be room to generate profit, if you like, both for a PlusAI for us as OEMs, but also a clear benefit for the customers. But I think more strategic and holistic, this, as opposed to the passenger car side, this is a fairly consolidated industry. So there's a handful of PlusAI type of companies, and there are a handful of international motors type of company. I'm convinced that we have the start of a winning equation together, both in terms of when I see firsthand our engineering teams take this on together and bring the hardware and software together and bring that alive with all the operational oversight that is required, and that alongside with our very strong commitment to bring these offerings into full commercialization with our customers. So I would like us to be back here with some of our most important customers and jointly see this grow rapidly, and that there is an equal share of benefit for all parties involved, because there is certainly enough for all of us if we make this a reality at scale.
Great. Thank you, Tobias, for your partnership. Looking forward to continue our win-win-win partnership. Thank you.
That's easy. Thanks so much. Thank you.
So you've heard from me the overview of the company, and heard from Tobias his view on the future of the autonomous trucking industry. Next, I'd like to introduce Tim Daly, our co-founder and chief architect of PlusAI, to give you an overview of our technology, which is the foundation of our business. So, Tim.
All right, thank you, David. Hello, everybody. Thank you for coming. I guess I'm going to show you a little behind the scenes now, how we actually build the stuff. So, yep. So just to give you the flavor of what we do, these are some videos from testing. On the left, you can see a closed course test. So that is a truck that has nobody in it. And it's running on a closed course, so it's safe. We don't have to worry about the public getting on it. And what we're doing is fault injection tests. So we're actually disabling parts of the system, turning off the main computer, turning off one of the actuators to make sure that the truck still behaves safely. So that kind of testing you can only do on a closed course. The other kind of testing that we do, you can see on the right. So this is a drive where we've got a safety driver in the seat monitoring the system, and we're just watching to see how it behaves. And in this case, it's in heavy rain. So we do a lot of both of those types of testing, and it's a lot of fun in case you want to come work with us. So this is the system we are building. I'll start at the top. If you look at the light blue boxes, that's the main driver of our system. That is what... I guess I was too quiet. This is better? Okay. Yay. Okay. So the top bit is the brain. And we call that reasoning. That is our name for our vision language model. So this is the newest part of our system, and it gives the system a kind of common sense. So that's been the hardest thing to build in the robotics world. It's easy to make an assembly line machine that just does the same thing over and over, but to build something like a plumber is nearly impossible, right? But the large neural networks trained on internet scale data have brought that capability to us. So now we have common sense in the truck. However, that model is not fast enough to make the instant-to-instant driving decisions. For that, we use reflex. That's our main driver. That is the big blue box in the middle, and that is an end-to-end transformer model. It takes all of the raw sensor data in, and it outputs what are some options for our vehicle to do next, and what is everyone else going to do next. And at the same time, it outputs the states of all the other road users, all the lane markings, all the signs, and so on. Now, that model would be capable of driving without outputting all that stuff, but we make it generate those interpretable outputs so that we can double check it. which brings us to guardrails, which is the bottom box, bottom blue box. That is a rule-based system. Now, it's almost impossible to build a self-driving system out of rules, but it's pretty easy to check a self-driving system with some rules. So because we've produced this local map information that has all the other road users and what they're going to do next, what we're going to do next, we can punch out trajectory sets with guardrails if they look bogus. Because it's rule-based and mathematical, we can prove that it will always work. That's very hard to do with a neural network, so we bound it with this system. Now, it could be the case that that main computer has caught fire. So we have a physical redundancy also in the truck. That's the green box. So that is actually running an older version of our system before we had the really big neural networks. We've been working on this problem since 2016, and we've developed many very competent drivers in that time. So the redundant safe fallback system, it's on a separate computer, separate place in the truck, separate power domain. It's very hard to break it at the same time as the other one. And it's more than competent enough to get us to a safe state, pulled off onto a frontage road or stopped on the side of the road. Finally, the last bit of the equation is our remote operations. Now at Plus, we don't believe in remote driving. The driver never takes a hold of the wheel and steers, because you could lose that connection at any time. Instead, the driver helps the vehicle make decisions. A typical example would be if our vehicle has pulled over to the side of the road because of a fault or bad weather or something like that, the remote driver can tell it it's okay to restart. So starting with that reasoning model, I'd like to go a little bit deeper into it. So most of the data that self-driving companies have historically worked with has been from their own fleet. You drive around, you gather sensor data, and you learn from it. Thanks to the vision language model paradigm, we can just take internet scrape data and train the model off of that. And it gets even better because other companies are doing that for us and sharing the models, so we can take advantage of them, so we don't have to pay that huge training cost. The ability to reason out a new situation, to have a kind of common sense, is really a game changer in terms of broad deployment and scaling. It helps you to argue about edge cases that you have not observed before. One of the reasons for the long deployment timelines historically for self-driving systems is in an open world, anything could happen. And if you keep collecting more data, you keep getting more weird examples. So this helps us unblock that. Here are some examples of the weird cases that our reasoning model can handle. Here we've driven into a construction zone. There's a guy who looks like a construction worker. He's got a stop sign. And there's a steamroller. And we should avoid them both. And the behavior plan from our reasoning model understands that, just like you or I would. Here's another example. You can see the traffic jam, but you don't know why, and you wouldn't know that you need to get left if you can't read that sign. But reasoning can read that sign. It says that the right lanes are closed, so we know that we should start moving over. That makes us a better participant in traffic. This is another difficult case for an autonomous truck developer. You have to decide in a split second whether an object on the road is overrunnable, so low enough that we can ignore it, or not, whether it could cause tire damage or not. But there's an endless variety of objects that could be on the road. You're never going to get enough examples for a standard detector model where you've trained on a specific list of classes. But reasoning can work it out. It knows that that's a barrel of some kind, and we should change lanes. Here's another case. There has been some accident or something, and a truck is on fire. There's a police officer in the road. As a human driving here, even if you did not understand what's happening in the scene, you would know that it's weird, and you would become more cautious. Reasoning allows us to do that as well. The model knows that this is an outlier situation. It knows there's emergency vehicles and a vehicle on fire. It describes it to us. It also produces action encodings that we can interpret so that we know what we should do, and we know we should be cautious and slow down in this situation. So as I mentioned, reasoning is smart, but it's not quick enough for the instant real-time driving decisions. That's what we use Reflex for. That is our main driver model. Reflex is an end-to-end transformer model. It takes in the raw sensor data, and it outputs what you see on the right there. So you can see the lane markings and the other vehicle states. One of the constraints that we face as a self-driving developer is you have to use the computer in the vehicle, and there's a limit on power and space. So if you look at the really big chatbot companies, they can just use data centers and data centers full of computers. They're buying up all the DRAM in the world and so on. We don't have that luxury. So we put a lot of work at Plus into getting the smartest model we can onto the computer we've got in the vehicle. And that's what reasoning is. Reflex. These are some examples of the outputs from the reflex model. Something to notice when you look at these, for other vehicles, the most likely trajectory is blue, and for our vehicle, the most likely trajectory is green. But there's a second option and more for everybody. We're only showing the second one here. And you notice in these videos, it starts with a mix where there's a red that's pretty strong, and then that kind of collapses once we work out what someone's going to do. So for example, on the very centermost video, you can see that someone is merging onto the highway. So our vehicle is running on the rightmost lane, and someone's taking an on-ramp. And it takes us a moment to decide, do I go in front of him, or does he go in front of me? And you can see it become certain. Similarly, on the right, we are merging. And we have to decide, are we going to accelerate and get in front of that guy, or slow down and get behind him? And this is a case where people will even look at each other and wave and things like that. It's one of the harder problems in self-driving. But Reflex is able to work it out. This is an example of the raw output from the Reflex model, and I'm showing it to you to underscore a point, which is that these are not your traditional computer vision labels. It's not bounding boxes. It's not class information. It's 3D. We need to make 3D examples in order to train this model to output 3D maps, which is a very hard problem. Humans can't just look at a bunch of pictures and LiDAR point clouds and draw a nice 3D map. So the final layer is our guardrail system. That's the rule-based system that I mentioned. This doesn't just keep the vehicle safe. It also allows us to encode rules. So for example, if you can't turn right on red on Sunday at a particular intersection, we can put that in guardrails and punch out that trajectory and guarantee that it won't do the wrong thing. We also value the explainability of the outputs from our reflex model because it helps us make progress. Often when you make an end-to-end neural network system, you can get stuck. It's like playing whack-a-mole because you find that it doesn't do something right. You add training data or you teach it a different way. You fix that and a new problem arises. With the explainable outputs, we can debug a little bit. We can understand why. What about the data that it saw got it there? What's going wrong? So we don't get stuck. It's also important to know that the vehicle is doing the right thing for the right reason. You wouldn't want it to be proceeding at a certain speed and not see the guy in front of it, right? So it's very important with the explainable outputs, we can verify that it does the right thing for the right reason. In order to make smart models, you need to have a great data set. All of the new AI tech that is changing the world right now is based on giant data sets. The chatbots were trained on internet scrapes. While we are able to take advantage of that type of data, we need sensor data from our actual platform to get the best performing driver. So since 2016, it's been a top priority of the company to do diverse driving. We have had over 100 vehicles embedded in the Amazon fleet for years, bringing us data. We have had focused driving efforts of our own to drive all the interstates in the country. We've covered most of Europe. We've got driving in Japan. We've been driving in Australia. Those are markets where they drive on the other side of the road. That allows us to make a smarter driver. It allows us to prove that the driver is going to work even in really odd situations. And it allows us to train a much bigger neural network. Because if you don't have enough data, it'll just overfit. So the number here is 5 million. We're actually over 7 million miles. Inside the company, we have great systems for slicing and dicing that data so that people can find more examples of hard cases, for example. So here you can see, if you put these queries into our data system, what comes back? There are millions of queries like this that you can run. And it uses neural networks to find the image data automatically. It's not like people had to go label them. The data system is fully automated, and it is the foundation of our training. If you look at some of these cases, like the rainy roads, you can see why it's important to get this data. That looks so different. If you look at the features, like the corners, the type of low-level features that a model might traditionally have used, they're completely different. So that's a big back-end focus. Here's some of the other weird stuff we've picked up just to give you, just for fun, I suppose. We've got trucks on fire, we've got a kangaroo, and this gentleman on the right popped a wheelie and played chicken with our vehicle. Now, a naive, older self-driving system might have even filtered him out, because that's too strange, right? But now we have an example. We know that can happen. Down here on the left, people are doing yoga in the parking lot. And it's a weird lighting condition. And they're lying down on the ground, right? That's a very interesting case. I'll just put it that way. So how do you make labels for this reflex model out of that data? Because you can't just feed it raw data. It's not a pure generative model. It's not big enough for that. We do what we call joint auto labeling. And you can see an example of a joint auto label on the right. This is from Japan. So you get a dense ground surface, and you get dense point cloud models of all the cars. And they move like they moved in the original scene. But it's all 3D. And that gives you something that when you're training the reflex model, you can check its output against and feed back the errors so it will learn. Here's an example of one of the ground maps that is an input to the auto labeling. One of the things I want to underscore is the goal is not perfection. The goal is scale. With auto labeling, you're not paying people, and you're not paying per label. Instead, you're paying developers to build a system that you can run on all of your data. So as long as the noise is not harmful, in this case, we've only driven this highway once in each direction. That's what the red little frustums are about. So we don't have a perfect view of the most distant lanes from us, but it's okay. The reflex model can still learn perfectly well from this, and it's better to have more data. So simulation is perhaps the most important topic in all of self-driving, because when you do a test drive and then you change the version of the system that you test drove, you sort of invalidate that test drive. You need to be able to repeat it. It's super important. But there's a new problem, which is that these very smart models that we have now, like reasoning and reflex, they can tell whether it's a simulator or not. The computer game engine-based simulators are just not good enough anymore. The model responds in a totally different way. So we have a neural simulator that works using radiance fields and is able to adjust the original image data, the original LiDAR data, the original radar data to accommodate for new vehicle poses. And that's what you're looking at here. So on the rightmost one, for example, we did not drive in the oncoming lane, as you see on the bottom. We drove in the right lane. But we can make a simulator case where we're on the left side. Right. Another type of tool that we use in simulation is to take advantage of generative AI models, like NVIDIA's Cosmos, to multiply every scenario we've collected into a myriad new ones with different weather, different traffic conditions, and so on. So here you can see an example where the original real data is on the top, and we've made it a very rainy night or just a clear night, getting multiple drives for the price of one. And we can repeat that validation on every new version of the software. That was it for my slides. Thank you very much.
So for the next, I guess, 30 minutes or so, we have a Q&A session. Tim, you want to come up here? Happy to take any question with regard to technology or any general business questions. We do have an afternoon session about our commercialization and as well as our financials. So save your question if it's in those two areas.
Maybe let's start with Ken, then we'll go to George, and then Jesse.
Vanished.
Ken Hexter from Bank of America. Thanks for the presentation. Thanks for having us today. Really interesting stuff. And I guess, David, I'm going to start one with maybe Tobias kind of brought up some really interesting things about culture and what you've done. But Tobias,
just tested both of them in person.
Too simple in the past having an agreement with
We've turned them on too.
With the company before. Can you talk about the difference in technology? Is there difference in technology that you see that you say fits better now that you're ready to move forward with? Can you address that at all in terms of the differences and kind of how you build it into the trucks? And then Tim, really great stuff on Tim on the kind of the technology, but does reflex allow it to go outside the guardrails, or does reflex mandate it stay in the guardrails? So let's say there's an accident in front. Will it know enough that, hey, I can go into the lane on the right to get up to avoid? Like, I just want to understand.
That was a lot of questions. I think you've underscored the flaw in having David repeat the question.
Okay, so I'll repeat the question and then we'll have you answer the second question. So first question is actually to Tobias. The question is about, you have worked with a few technology companies in the autonomy space, including Too Simple, right? Can you articulate the differences, in terms of your experience working with various companies?
So if there are more questions coming my way, I will come and join you. Actually, I was not personally deeply involved in Too Simple, but of course we have done a rich lessons learned from that. There was not a big problem with the actual technology, the actual software of Too Simple. Where that failed was actually much more on the integration, both technically the integration and then actually the actual partnership as well. And I think that's why, to the question before, why the culture, why the collaboration, why the transparency became such an important element of the criteria when we later on decided to work with Plus. That was, of course, based on that experience. These systems are simply too complex for not having the best of engineers on both hardware and software working it together and integrating it together. So I would say that failed more, and then it started to fail more on that culture collaboration side, and then many of you know the full story of that. It failed for other reasons as well.
Perhaps you want
You can do the second half.
I think, yes.
Second question.
Yes, the second point you want to, ask it.
When you answer the question.
Yeah. So I think the second question was, can our reflex model drive outside of the guardrails? No, that's the point. So if it does anything that we've declared illegal in our guardrail system, we literally delete that trajectory. And if it should be the case that there's no trajectory left, we would do what's called a minimal risk maneuver. The truck will just stop and just give up. That's the point of it. So if you want to prove once and forever that something can't happen, you need to do that mathematically. And it's very hard to do in the neural network world.
George?
Two questions for me. The first one is for Tim. I think from the beginnings of Plus, you sort of re-architected the system to make it more AI-centric. How flexible is it so that it can take advantage of any future changes in AI paradigms? And the second question.
So I think that flexibility is more about people and culture than about the technology. it's really easy to get hung up on the investment that you've already committed to an older piece of technology and think, well, maybe we should just push this over the hump. But we have a culture where we always assume that the future is going to be much bigger and brighter than what we've got right now. We're going to grow, the market's going to grow. And so we are always betting on the most modern tech. Now, it's a somewhat scary thought to think that it could get more advanced than it is. I don't know what that would look like. Maybe I won't be doing the programming anymore at all. I don't know. But that's our culture, is always get the best of what's available.
Maybe a question for you, Tobias. How interested are your customers in autonomy broadly?
So I thought I answered to that before. It's a top priority for us. It is as a consequence of it being a top priority for our customer. It was certainly not the case only 2 to 3 years ago. So it has shifted significantly. I took on this job a bit more than 3 years ago with responsibility for electrification and autonomous. And I would say 9 conversations out of 10 was actually on electrification. Today, it's definitely the reverse. And it's not only that autonomy has been proven in commercial vehicles. I think the development we see on passenger cars and on the robot taxi is creating a lot of momentum and building increased trust as well. So both that and what we see some examples of commercial autonomous transport as well. And then for the fact that this is truly based by market forces. Electrification, as a contrast, was very regulatory driven, and for that reason, us as OEMs had to try and push it and see what was possible. There is none of that in autonomy. It's 100% driven by an industry demand and the desire of customer, and they are super excited. Then I speak actually mostly about larger fleets. But larger fleets, if you would take 20 to 30 named fleets, that's almost half of the industry and consequently half of our business. So that's a very good starting point for the long tail of different type of use cases and fleet operators is more general excitement. But the big ones, they are very serious about this and are setting up teams and planning to take it into operation for sure.
Yeah, I got a question for Tobias and one for Tim.
Yeah, we should have Tobias come up here.
So clearly your customers are really interested in autonomous trucking. From a practical standpoint, how quickly can they adapt it? Like, what do they have to do in terms of adapting workflows, doing their own integration? Like, how quickly could they actually, get to, 20% penetration, let's say? And then I guess for Tim, you talked about real world data, synthetic data. What's the relative importance of that sort of over time? How does that evolve in terms of you're building out the model?
You want to go first?
So why don't we have you go first and then
Okay, I'll go first. So is your question about how much synthetic data versus how much real data?
Yeah.
Is that?
Yeah. So, and the synthetic data is getting more important over time, or is it always be a kind of important use?
So the important thing for the synthetic data, which is, whether you've created it from whole cloth or by massaging real data, is you need the model's responses to look like they would look if it were real, right? That's the definition of realism. It's not even that it looks real to you and me. It's that it looks real to the model. Because otherwise, you're either learning something that's actively harmful, the model's not going to get better in the real world from that data, or if you're using it in simulation, you're testing in a way that's not meaningful. And so that's the limiting factor. And what's making us able to create more synthetic data is the powerful generative models. So models that have been trained on internet scale image data are much better at making realistic scenarios, but it's still, I'd say it's like a 30-to-1 ratio or something like that for every real example. We can fan it out to maybe 30 meaningfully different, but still realistic enough to be useful for training or testing scenarios.
Hey, my mic is working. I don't know. No, okay. So the question was in terms of integration of our customers and how complex that is for the fleet operators. Yeah. So I think that's one of the reasons if I came across as slightly vague on the exact timeline, that is not due to any doubt in the actual software or us being able to have the hardware ready, but it's for the reason of that complexity, because it adds complexity, of course, initially. Then I think eventually when you start to have 20% and 30 and 40% of your fleet, then I think that will flip to actually providing simplicity and automation. But of course, these are odd vehicles the first time you introduce a couple in a high volume fleet operation. You start to introduce some of these. That's additional complexity. For that reason, what we do is, of course, to really try and find relevant use cases to start with. So even if this will be destination to destination, point to point, initially we try. So in this case, we have very good infrastructure where we pick up goods in Laredo. We have a large automotive factory that we now bring goods to that is in close to the relevant freeway, etc. And you all know that we have the idea is to start by hub to hub. I think we all see the capability of these systems to go on surface road as well, that we start to think point to point. But it is a low-hanging fruit to do a lot of miles on highways, on freeways, repetitive roads. So as long as you start with that, I think there is sufficient low-hanging fruits, if you like, where it's quite doable. And we don't see this, you should never say never, but we don't think of this as being 100% of all transport, Now it's about getting the first 20 to 30%, and there will be enough traction for it to self-grow. Then if we end up in 50% or 75% or 90%, that's to be seen and nothing we actually spend time on.
Okay, great. If we can direct more questions to David and Tim up here, so we can talk about Plus and not put Tobias on the spot to give every secret that TRATON's doing.
Sure, I got a question on the, you mentioned on reflex limited by the compute on the vehicle. So when you look out 5 years, the bigger models, more compute, or is there an opportunity on the roadmap for tighter models that can achieve the same thing, reducing the commute? And some of these trucks I've been in, the compute and the cooling is pretty big. It takes up most of the trailer. God knows how much power it's taking, even with a gas-powered vehicle. So how do you see that roadmap playing out? And then a second question on this. Satellite connectivity with LEOs is getting you down to like 13 milliseconds. Mm-hmm. Does that ever provide any ability to offload any of this? Thanks.
Yeah, so the last one's easy. It may make a lot of sense to put a Starlink terminal on top of the vehicle to get better connectivity. You still can't trust something. I never trust a connection without a wire, right? But that's a great idea. As for will the models get bigger and smarter? Yes, and the computers will get faster. But we don't want to consume too much power because you eventually will ding the fuel efficiency of the vehicle, and that still matters. With the driver becoming less of a cost, the fuel becomes a larger fraction of the cost, so it matters even more. I remember seeing, so there's an old thing called the DARPA Urban Challenge, and I saw one of the vehicles. They actually had a generator, like a gasoline generator, in the trunk to get all the power for the computers. So thanks to companies like NVIDIA, we've got really power-efficient computers now. We don't put anything on the trailer. It's all in the cab.
So does that cost decline up with that, or does it go up? Go up over time, either in terms of amount of compute purchased or,
The cost for the equipment on the truck is declining rapidly. The sensors are getting cheaper and more scalably manufactured. Well, also the computer, the computer, all of it. It's still, Moore's law is still holding in some sense. Yeah. Thank you.
Hi guys, Jesse. The 7 million miles you guys mentioned, it sounds like it's a lot compared to others in the industry, and you also showed it was across quite a range of geographies. I would assume this technology will always be iterative, but how does the scale of your testing compare to others in the industry today, and exactly how close is the SuperDrive platform to being commercially ready?
I don't have insight into exactly which data our competitors have collected, but I know that we don't encounter their trucks when we're driving in Europe or Australia or most of the US. So it can't be a very interesting data set. I wouldn't trade our data set for any of their data sets.
Mike Ward with Citi. It seems like the reflex part of the model is the most complex. Is there a way to gauge how far along you are? Are we at 90%? I assume it's never ending as far as the learning phase.
In terms of complexity, it's different. So if you look at the parameter count without disclosing it, the reasoning model is the biggest and most complex. But the reasoning model is easier to train because it's generative. So it's working in the space of text and images also for its output. So you don't need to label anything really. What makes reflex complex is we need to make these fancy labels to make it work. These 3D labels of where everybody is and what they're doing. But that's a very hard problem. That's one of the bigger engineering efforts at the company, is that label generation effort.
Okay. David, as relates to TRATON, do you have an exclusive with them? Do they have an exclusive with you? I think Tobias mentioned that they'd been working on the technology for 5 years. Did they give it up and turn it over to you? Do they have other partners they work with? How does your relationship with them work? Are they paying you now for the work you're doing with the development?
So we're going to dive into commercialization later on this afternoon. But as far as we are aware of, we are the only partner TRATON has for on-road, on-highway autonomous driving partner across all of their brands.
Hey, great. Ken again. Where is the technology now, right? So you showed the pictures, Tim, of snow and rain. Are you able to drive in all weather conditions at this point, or is it still a learning phase? And then you mentioned, Dave, you're leaving the driver in still. Is that the TRATON mandate? Is it a safety mandate? Is it what is the point where you get confidence to take the driver out pre-commercialization? Thanks.
So let me take the second question. I can do the first one. So we have a couple of top-level performance metrics we watch closely. One of them is called SCR, Safety Case Readiness Metric, which encompasses all the safety cases that we lay out to be able to prove that the truck is safe to operate under all of the operation design domain we designed the truck to operate in. That metric, we materially improved that metric from 75% to 90% over the last year. And we have the target to have that, to close out that safety metric to reach 100% by the end of this year for the Texas routes. And that's the metric that we watch to be able to safely take out the safety monitor or safety driver from the cabin and turn the truck into a driverless truck. And then we can talk about that more this afternoon.
So I think your other first part of your question was about, do we drive in snow? Do we, drive in inner cities, that kind of thing, right? So we have the concept of the ODD, the operational design domain. That's the set of conditions where we allow it to operate. And the idea is you want to have a bigger capable ODD than your permissible ODD, because things can change suddenly, right? So if it starts snowing in Highway 280 in California, all of a sudden, yeah, we're going to be able to handle it. That's within our capable ODD. But snow is not yet part of our permissible ODD. So to get there, we have to do more focused testing and prove more to ourselves that we're ready for that. But we've got tons of snow data, for example, and we'll do that one day.
Thanks.
Just one question for me. Let's assume the chips get way better, lighter. Let's assume the models get better. What does it take from an architecture perspective to do something like platooning? Is that require some further breakthrough, or just maybe a long-term question about that?
Sorry, I couldn't hear the tuning?
Platooning.
Platooning. Oh, Thank you. The issue with platooning is not the technology, it's the other drivers, I think. People get in between the trucks and break the platoon. So if you have a level 4 truck, you can absolutely do platooning, but you're going to have to make the calculation, is it worth it to pull over and pass someone just to get back in behind the truck again, right? And it also sort of assumes that your logistic flow allows for sending these dual loads at the same time for it to work. So platooning is not like a deep technical problem. It's a road user behavior and logistics problem, I think.
I had a quick question on the scalability of the system. How quickly can you approach getting into new geographies and new lanes, especially once you are able to take that driver out?
Very quickly. So you have to have the data. Normally, if a self-driving company goes to a new place, you'll see them drive around a bunch with the driver already in. And we've been doing that a lot of places already because we want to have that great data set. So most places in the US, for example, we would already have the validation data on hand. We could skip a lot of that driving.
So are you map-based? Do you have to have the map in the system, or are you learning on any road?
So we treat the map in our system like another sensor. It's the only sensor that can see around a corner, right? Nothing else tells you what might be coming around a corner. So it would be moronic not to have a map that tells you what happens around the corner. But you also can't be dependent on the map because you can't use a map unless you know where you are on it. You have to have correct localization on the map if you're going to trust it. And localization is a hard problem, right? You've got GPS satellites, but they're affected by weather. And they're not under our control. They can be jammed. Somebody could turn them off one fine day. It's actually a military system, right? So you can't guarantee that that's going to be working. So you can't guarantee that you know where you are on your map. So we use it as advisory information. It can keep us from going into a curve too fast. You can put annotations on it, like, hey, often people park here. This is a common place for there to be a vehicle on the shoulder. But you can't use it as a safety critical component of the self-driving system.
Hey guys, it's Mike Schlisky of D.A. Davidson. Do the fleets or customers have to adopt a separate software or another company to engage to figure out which routes are the ones that will be able to use your system? Or is it all part of the package? You've got a way to help them identify where are there no weather risks for the next couple of days, where are there no major hills or weird elevations and things like that.
So they would give us the routes that they want to run it on, and we would just tell them which parts are supported at the current time. And as we release new sections, we would update them. And they don't need special software for that. They would just communicate with us regions or roads that they use.
So it's actually factual. There's no evidence.
No, I'm sorry, I didn't mean to imply that there's no evidence involved. It's just that we are, Plus is responsible for collecting that evidence and proving out the system, not the fleet. So by the time we release the system to the fleet, it comes with training and instructions for how they can and cannot use it. And the vehicle itself will prevent itself from going out of its ODD. So if you reach a limit on your ODD, whether it's the weather and visibility or it's the place you've gotten into, it stops all on its own, whether they like it or not. So we're not really concerned about them like hot dogging it and trying new routes.
All right, any other questions?
Hi, so I'm just wondering how many commercial pilots are there right now? And maybe you could describe what some of those lanes are like other than the one out of Laredo. And maybe what is the trajectory of taking on new commercial pilots? How many do you plan to take on in 2026? Are there any new geographies that are particularly important to take on in order to prepare for that 2027 launch? Thanks.
This is actually a great segue for the afternoon session. So we're going to specifically talk about those topics, those questions.
Great. Any further questions? All right, we're going to take a 10-minute break.
All right. Good afternoon, everyone. I'm Sean Kerrigan, COO and co-founder for Plus. So I'm going to talk this afternoon about our commercial strategy. So to start with, I'll talk just a little bit of some background and context on the industry. This is just a massive sector if you look at the commercial trucking sector globally. And it's a sector where it's basically has the largest labor dependency, and that labor shortage that's occurring globally now is really one of the things that's helped a catalyst for the growth and development of autonomous trucks. Now, the other thing that's very notable about autonomous trucking is that we operate in a structured operating domain. So Tim talked about earlier how we operate then from a customer depot to the highway through the highway network into a depot on the other side. So those are all fixed routes where we can operate and expand the network segment by segment as we continue to grow. And then the customer demand here, you heard from Tobias and others in terms of there's just overwhelming customer demand for this now. This is something that the fleets, I think, all see is basically the biggest transformation to hit freight transportation since the invention of the diesel engine. And this is just really transformational for their business, both from a financial perspective in terms of ROI per truck, but then also just in terms of being able to relieve the bottleneck they have in terms of the driver shortage today. And you also heard earlier, right, there's very strong interest in backing from OEMs in this market. And so we're really proud of the OEMs that we collaborate with today. And I'll talk quite a bit more about that. As the OEMs in the trucking market, as distinct from, say, the robotaxi sector, here that's a very consolidated market, and the OEMs play a critical role in terms of bringing this technology to market. So we're partnered with some of the largest global trucking OEMs, including TRATON Group, so that's International Motors here in the U.S., as well as Scania and MAN globally. We're also partnered with Iveco, who's another major global European OEM. And we are partnered with Hyundai as they're bringing their hydrogen fuel cell trucks here to the U.S. So these OEMs play a critical role in terms of bringing this technology to market. And so I want to talk a little bit about how we work with them and then why the OEMs we see as a critical channel to deploy this technology. So this shows basically a diagram of the overall stack of kind of who does what. And you can see we focus then on the software layer of delivering the SuperDrive software system into the market. So we provide requirements and reference hardware specs to our partners in terms of the radar, the LiDAR, the cameras, the compute, basically all the equipment that needs to go into the system is part of what we provide to them as the specifications. And then we work with them as they integrate that into their trucks such that they can then sell it to their customers, the fleets, and deploy that as a service that then they are supporting. So this is really important because as we do that, we have a very sort of capital-light, SaaS-like business model where we're providing this software to our partners as they deliver these autonomous trucks to their customers, the fleet. And so it's because of that focus that we're able to have this really asset and CapEx-light approach of delivering software in this way. And it's also, if you look at the industry structure and talk to the fleets, you'll see why they all want to be buying this through the OEMs. So if you look at sort of the industry structure and look at how the market works today, OEMs play a critical role in the trucking market. And as we looked at what would be the best way to deploy this technology globally and scalably, it really became quickly apparent that there were some really important things that fleets look for when they're going to be buying this technology and start operating these autonomous trucks. So first is that they have long-standing relationships with their OEM suppliers. So most major fleets buy from two major OEM suppliers, and they've built their entire service support network around that. They also have long-standing trust in that OEM is basically companies that have been building trucks for 100 years in some cases, right? And have stood behind them in terms of designing trucks that are going to last and can be maintained and supported and will be safe, right? So that's the counterparty that the fleets are buying from today, and that's who they want to continue to buy from in the future. Now, it's also important to note here that trucks have a 1 million-mile design lifespan. So it's one thing to design a system that you can integrate into a truck and have it work for tens of thousands of miles or hundreds of thousands of miles. All right, so we do that with some of our R&D trucks where we're prototyping and testing new things. But it's quite another to develop a system that can be integrated into a truck and have it work reliably for 1 million miles, be serviced and supported for 1 million miles. And that's what OEMs really excel at, right? And so we thought it was critically important to deliver our autonomous trucks in that same way. Autonomous trucks, as they drive about 250,000 miles a year, right, having trucks that are truly reliable and maintainable becomes even more critical. And then finally, this isn't about deploying, tens of trucks or hundreds of trucks. This is about deploying tens of thousands of trucks. So the only way to do that is to be able to factory produce them in volume and service and support them in volume. And so it's for all those reasons. It's basically that long-term trust is their counterparty in terms of the ability to have a reliable, serviceable truck and being able to produce them in volume, that the OEMs are critically important when it comes to delivering autonomous trucks at scale. So with that in mind, we sought to build a very strong set of OEM partners. We're super excited about the partners we have today, including TRATON with International Motors and MAN and Scania, also with Hyundai and Iveco. And as you look across the market, it's fairly consolidated. So if you think about all the global OEMs that operate across US and Europe, that's who's on the page here, right? And all of these OEMs, as they thought about selecting partners, realized that this was a big investment for them. You heard earlier about the amount of investment and work that goes into integrating these into the truck. So that's a big commitment from the OEM themselves as well. And so that's why in all of these cases, I think these OEMs spent years selecting what partner they would work with, and now they're spending years integrating that technology into the vehicles that they'll then be selling to the fleets. And so if you look at basically what does the outlook look like for delivering autonomous trucks at scale, basically the table is set in terms of who are the OEMs and who are the autonomy companies that have those types of partnerships. And so we're really proud to be among the set here that can deliver these products at scale to customers. So now I'll talk about each of these partners in a little more detail. So the first, of course, we've heard a lot about TRATON and International today. And you also heard about how there's been an increase in terms of the priority of getting this technology deployed. So we were excited to announce just a couple of weeks ago this new autonomy acceleration agreement with TRATON. And so, we've worked with them for quite some time. We announced our partnership back in 2024, and last year we started the customer fleet trials in Texas. And now with this acceleration agreement, I think it shows just the really deep alignment we have between our companies in terms of deployment. In terms of the additional $25 million in terms of R&D support for developing and deploying this technology, as well as putting in place the strong commercial alignment where we have warrants with revenue targets and strike prices above our IPO price. And we're excited to have TRATON representation on our board going forward. So I think this makes for really strong alignment around this really strong partnership to bring this technology to market. Next, I'll talk a little bit about Iveco. So Iveco was our first major European OEM partner. So we started here in the US, and you heard Tim talk about our data strategy. So we thought it would be really important to develop a global footprint for our technology and our deployment to collect that broad and diverse data. And so we have this longstanding partnership with Iveco, a major global OEM based out of Europe. And with them, we've been collaborating since 2021. And so that gave us our initial exposure and data across Europe. We've worked with them on a full range of automation, everything from advanced driver-in solutions to level 4 driverless. And we're excited that we just recently announced the start of a new pilot with them, a 3-year program in Spain. So this is a level 4 pilot that will be operating on a corridor near Madrid. And working with SESE, a major logistics company out of Spain. So that, again, is going to give us a broader set of experience, more data, more exposure, and really prove out the ability to commercially deploy this technology in Europe as well. Here I have a short message from Marco Liccardo, the Chief Technology and Digital Officer from Iveco.
At Iveco Group, we believe vehicle automation will play a major role in how our customers move goods in the future. It will improve safety, increase efficiency, and reshape logistics. To drive the development of these revolutionary vehicles, we needed a partner with the same ambition, the same technical depth, and the same long-term vision. Since 2021, PlusAI has been that partner. From the very beginning, it was clear that our strengths fit together in a uniquely powerful way. Iveco brings over 50 years of engineering excellence and global industrial capability PlusAI brings a true AI-native autonomous driving system that is built for commercial tracking and designed to learn, adapt, and scale. Together, we are creating the next generation of commercial vehicles, automated and fully autonomous vehicles that will define the next era of freight. We have made significant progress together over the past several years. Our joint testing and pilots with the customers like DSV have enabled us to integrate, test, iterate, and mature a very advanced Level 2 Plus platform. Together, Iveco and PlusAI are now working to bring Level 4 autonomous trucks to Grupo CC in Spain. And this is a bold step forward for Spain, for Europe, and for the global logistics community. It is a glimpse of what freight transport will look like in the future: safer, cleaner, smarter, and far more efficient. You see, Iveco Group is doing more than preparing for the future of trucking. We are building it, and we are proud to go beyond with the PlusAI as the partner by our side.
And next, I'd also like to talk a little bit about Hyundai, another OEM partner we're really excited about. So with Hyundai, we announced this a couple years ago, and then last year we announced our sort of shared vision and strategy around applying this technology into hydrogen fuel cell vehicles. I think this is an exciting application because it really highlights the synergy between autonomous technology and some of these new, say, electrified or hydrogen fuel cell type vehicles, right? That synergy comes about for a few reasons. So one is that these types of vehicles tend to have a higher initial CapEx, but lower OpEx associated with them. So when you can triple the utilization of the vehicle, you can substantially improve the TCO for the operation of that vehicle overall. And the second thing is these types of vehicles also come oftentimes with the need to add additional infrastructure, whether that be hydrogen fueling infrastructure, charging infrastructure, and so on. And so how you think about building out that additional infrastructure pairs really nicely with how you think about expanding an autonomous freight network segment by segment across the land. And so this is a collaboration we're excited about with Hyundai. Now we have more. So Tim talked about, part of our strategy is getting that global expansion, getting more data from more places. And so the most recent one of that was expansion into Japan. So building on the back of investment by Mitsui, we partnered with T2 in Japan. And so we think this is a fantastic opportunity in terms of Japan. If you look at the market, it has basically all the same challenges and drivers for adoption that we see here, right? In terms of a huge driver shortage, aging population that's making that an even more accentuated problem. And so there's a big push to see how they can bring autonomous technology to market. So in this collaboration, working with T2, which has this depth of sort of technology and transportation and logistics expertise in Japan, right, along with our software and our technology, we think that puts us in a fantastic position to be leading the charge in terms of deploying autonomous trucks into Japan. And then with the backing of Mitsui, right, obviously is the major Japanese trading house. They're a company with just tremendous both financial and logistics reach across markets all around the world, not just Japan. And so we think this is a great foundation as we look to continue to expand where we deploy our technology. So now, that was just a quick overview of some of our key partnerships. I'll talk now just more generally about how we're approaching the deployment of that technology and what our roadmap looks like. So oftentimes we get the question about what does the regulatory landscape look like? And so on this picture you see here, everything that you see in sort of teal and light blue, you can already commercially deploy autonomous trucks today. And so that's basically all across the US with the exception of California. And California is likely changing later this year. And for those of you that have been following these maps closely since we first released it, you'll see that some of the light blue has turned to teal as there's been just further progress. I think this is an interesting space where it's one of the seemingly rare bipartisan issues of the day, right? This is something that on both sides of the aisle in the U.S., there's very strong support for the deployment of this technology because it has such a positive impact in terms of safety and because there's so much demand because of the driver shortage. This is something that really is getting a lot of support for deployment. So that's the picture in the U.S., and we think that picture is only going to continue to improve, right? Because we see that, both within with the current administration, this is a priority to get autonomous technology deployed, right? And we've seen progress on that. So, for example, the DOT released an RFI last fall looking for what are all the points of friction and how can they streamline those points of friction for deployment. And there's action has started to be taken in terms of dealing with these warning triangle issues and some other things, right? So we think the regulatory picture is quite positive and only trending more positive as we continue to progress here. Now, in Europe, it's actually quite similar in many respects. So you can see that there's a strong corridor of countries in terms of Sweden, Germany, France, and Spain, where you can deploy this technology. The driver shortage of 80,000 drivers and growing in the U.S. is even more acute in Europe, almost twice as big. And so all the same drivers in terms of the lack of drivers for the trucks, as well as the importance of safety, has really brought this to the fore. Is something that they're also making big strides on the regulatory front to further permit this technology. So we think that the outlook is really bright in terms of having very broad deployment. Now, we plan to commercially launch first in Texas and then span out across the U.S. Sunbelt and then expand from there to Europe and elsewhere. And as Tim talked about, we have already today collected data across all those different areas. Right, we run the same software on the trucks that we're operating in Texas as we do in the trucks that we're operating in Sweden. And so we collect data across all these different geographies and really have the whole system primed for commercial deployment as we get there. So, I think we're very well positioned for global growth. Now, in terms of the Texas operation, we operate all around Texas Triangle and sort of offshoots from that Texas Triangle. We talked about how with TRATON last summer, they announced the start of the customer pilots on the I-35 corridor. And so we're really excited about that. That, I think, is a very important milestone in terms of showing the commercial readiness on a few fronts. So one is that those trucks are all trucks that were produced in International Motors factories, right? They're now equipped with our software and the hardware to some of our specifications. And they have the TRATON or international safety drivers behind the wheel, right? And they're now moving freight for international customers, right? Going from the customer's depot to the other side of the customer's depot. And so I think that's really important because it shows both how advanced our technology and integration is. It also shows the level of trust and confidence that TRATON International have in this technology, because these are their trucks that they've produced with their safety drivers delivering freight for their customers. And then it also goes to what Tobias talked about earlier in terms of getting the experience of building this into the customer operations. Right, so this is a critical part of that. Right, there's, I think, tremendous pent-up customer demand for this technology, but it does still take a bit of time for them to get integrated into their operations at their distribution center. And so this is a critical step in terms of making progress on that front. And I would just say that as we made that announcement last summer, we also got a bunch of inbound calls from fleets saying, well, why weren't we part of this initial trial? Right, I think there's just a lot of pent-up demand. And so you'll hear more this year as we continue to expand some of those and bring others into the fold and expand what we're doing there. And then from a metrics perspective, we've made just tremendous progress last year and are on track to hit all of our targets for this year. So at a high level, we look at two key metrics. So one is the safety case completion. Right, so this is the structured safety case where we disaggregate that safety many layers deep. So it goes down about 3 layers in terms of what's published on our website, and it goes down like 5 or 6 beyond that. And we've made tremendous progress in terms of completing all the validation that goes along with all the things that underlie that safety case. So as you can see here, last year we progressed that metric by about 15%, getting to over 90% by end of year. And so we're well on track to get to 100% for that safety case completion for our Texas routes by end of this year. So there's a lot of things that went into that in terms of both structured safety analyses, different types of testing, some of which you saw in some of the videos earlier. as well as just hitting certain performance thresholds on different parts of the system. So we are, well on track to getting to the point where we need to be ready for that commercial launch in 2027. The other metric that we look at, we call RAFT. That's remote assistance free trips. That's ability basically to operate end to end from the distribution center to the highway through the network and off the other side without any need for remote assistance. So on that metric, we also made tremendous progress last year, increasing it by over 10%. And we're on track now to hit our target of over 90%. So notably, that metric does not need to get to 100%. Because there is this remote operations centers, and the intention is to always have that remote oversight. So it's really about getting it to a high degree of performance, and we're well on our way in terms of getting there. So with that, let me hand it over to Steve for a financial update.
Great. Hi there. I'm Steve Spinner. I'm the CFO. So let's dig in here on the financials a bit. So, our business model is not just highly attractive, and I know everyone here has looked at our S4 and has looked at our presentations online. We've tried to make it really straightforward for everyone here to understand. And the truth is that I'm highly confident that everyone here has understood it. The beauty of our model is in its simplicity. Simple on the revenue side and simple on the cost side. On the revenue side, we get paid for every mile that autonomous truck is driven on the highways. It's that simple. It happens for the life of that truck. That, coupled with the fact that we are, as others have said, we are a SaaS-like company with software margins that imitate our other companies in that model. On the cost side, we are very, very straightforward in the fact that our business model is unlike our peers. Ours focuses on that AI native approach, but that allows us to have far, far less on the R&D and far less on the operating side, operating expenditures. So the combination of all that allows us to be, of anyone in the industry, the most capital efficient of any of the companies, not just to launch, but also to get to scale. I guess we flipped it around a little bit. So everyone knows the numbers in the industry. It costs $2.27 to drive a truck, a regular truck today. Now, the largest cost component of that is the driver itself at 97 cents. Everything else is far, far less than that component. This is 43% of the total cost. So the opportunity with an autonomous truck is to be able to make a major dent in lowering the biggest cost component for the fleets. And that allows us to take on a lot of the issues that have been discussed today, which is affecting the costs of the driver, inflationary costs that they're dealing with, and as we've mentioned, the driver shortages and the aging workforce. So being able to make a dent in the largest cost component in the industry is transformative. And how do we do that? Well, it's two sides. One is to lower that driver cost. And the industry has kind of coalesced right now at about the 85-cent cost point. So the fleets will go from, rather than paying a human driver 97 cents per mile as a salary, to now they'll be paying the OEM, in our case, 85 cents for that autonomous vehicle, a savings of 12 cents per mile at scale. Separately, the other opportunity is to be able to have greater utilization of each of those trucks on the roads today. Now, right now, you have hour service limits. That is not an issue in an autonomous world. So now you can drive that truck way more than 11 hours a day, perhaps even up to 22 to 24 hours a day. That allows you to have much higher productivity for that individual asset, and as such, have much more revenue per mile for that asset. So that's the opportunity, is to have a tripling of utilization for that truck. So the combination of those two things allows for huge increases in profitability on a per truck basis. Now let's talk about the ecosystem here for a second. So our business model and the way we operate is, rather than change how or ask all the players in the industry to change to our interests, we just like to take it for what it is. This is an industry that's been operating for decades, even 100 years, relationships between fleets and their OEMs. Extremely trusted set of partnerships there that go long before Silicon Valley even existed. So we want to work within the system as it exists. So fleets buy their trucks from the OEMs. OEMs work with hardware and software players, us PlusAI being the software player, to be able to provide that truck for them to sell effectively to the fleet. But that works for us. That is our DNA. Our DNA is to do that software layer, do what we do really, really well, and not do anything else. To stay in our lane, to work with our partners, our OEM partners, and help them be able to sell these autonomous trucks to their customers, their fleets. And so what's nice about ours versus other companies in the industry is that each component of the ecosystem has upside from a profitability perspective that is unparalleled to recent history for them. So the fleets themselves, and we'll go into each one of these in the following slides, the fleets themselves on a per truck basis is able to increase their profitability on an annual basis per truck $65,000 of a profit uplift. The OEMs now are able to, and this is what really excites us especially, is they're able to go from historically being a primarily hardware company selling these trucks, these beautiful, glorious trucks to these fleets, to now be able to additionally get into the SaaS business and be able to have annual revenues from a SaaS model that rival the one-time upfront hardware sales that they have from selling that truck. That gets all of us really, really excited at Plus. For us, for playing that role and only playing that software role, because that's the lane that we like to stay in, we should get paid for that, but we get paid the minority of the value creation here for the role that we play. But our role is highly, highly lucrative, given that it's a software model. So each one has an opportunity to have massive increases in revenues and profits that are assigned to that. So first, on the fleet side. So as we mentioned, the biggest driver of change here is that delta from 97 cents to 85 cents, that 12 cents per mile. You take that and you triple the opportunity for that truck to be more fully utilized, and it takes the average profitability for a truck by a fleet from $18,400 per year, 4.5 times that, to $84,000. $65,000 of additional profit per truck, per fleet, per year. That's a game changer for the fleets. That's why they want to get involved. For the OEM, as we mentioned, their opportunity now is to participate and get that 85 cents per mile from the fleet customer. They provide all the services that Sean described for what they do. And that times the 240,000 miles yields them $200,000 of new revenue for them on an annual basis per truck, to which they would then pay us for being the software provider that $40,000 for doing that, 20 to 25% for being the DaaS provider. So that's $160,000 of new revenue for that OEM on an annual basis for the life of that truck. Now for us, as I mentioned, we get the $40,000 per truck per year for the life of that truck. As a software company, 85% margins. But we do what we do, so everything stays the same. So the fleets purchase the trucks from the OEMs continue to do what they've always done. They do the sales, they do the service, they do the support. We get paid our cents per mile, and that cents is 20 to 25% of the total value opportunity for autonomy. And our adoption curve on the right shows what we've published in the S4, which is we launched in 27 with a modest amount of trucks on the road, with a nice steady ramp a few years later to 25,000, to ultimately to 130,000 in 10 years. Now, what does that mean? It means that we can get to be a very, very nice business relatively quickly. So if you take that 20 to 25% of the value chain that is paid to PlusAI, once we get to 20,000 trucks on the road in the aggregate, not per year, in the aggregate, just 20,000 trucks on the road that have Plus Drive in it, or Super Drive in it, we get $1 billion of revenue. So that's, and as I said, 85% margins. That's a very, very nice business model. And it's very simple for people to understand and grasp. So from an operating expense perspective, and this is non-GAAP, please, the most important thing is to understand we are software. We don't have hardware. We don't have CapEx. That's the most important difference between us and everyone else in the industry. Those two things are massively effective in our ability to execute and go to market and fully scale. So only focusing on the software side, we're able to be a $75 million a year OpEx company. We'll increase modestly each year for the next couple of years. In total, we will spend a net $170 million from here to full commercialization, which clearly differentiates us from everyone else in the industry. We're different on the revenue side, but we're most different on the cost side. We do not have the costs of our peers. We don't do retrofits. We don't do our own autonomous freight network. We do the software for our partners. And in summary, for us, and we've mentioned this a little bit, it's really straightforward. With what we have already under contract, we can be a very, very large business. We just have to execute with our partners on their timelines. So one, we've got the deals, just put our heads down and do all the deliverables that Sean had shared and Tobias had mentioned earlier, and execute on the first one. That said, we have a great moat that we've been able to create here over the last few years through our partnerships in the geographies that we've executed on. In the United States, as Sean said, the table's set. There are no additional players for people to partner with. In Europe, we have our TRATON partners, and we have Iveco. We're the only ones playing there. We have a great moat to further expand in Europe. With our Mitsui partnership, we have a great opportunity now to additionally expand further into Japan and elsewhere. So we will opportunistically and strategically look for further geographic rollout with our partners. And then lastly, because of our unique model of focusing on the software side and staying in our lane and working collaboratively and in partnership with our partners, it's very attractive for other OEMs to want to work with us as well. So we get calls. We say no to most of them, to be honest, but the ones that we get, we always evaluate and will opportunistically and selectively look forward to expanding going forward for the next few years. And with that, let me introduce or bring David back up here to wrap up, and then we'll do a Q&A as a whole.
Thank you, Steve. Thank you, Sean. So you heard from our team today about our overview of our business, technology, our commercial plan, as well as our financials. But equally important, you heard from our partner about their plans and expanding the business in terms of taking autonomous trucks to commercialization in the coming years. But overall, the core message we have here is, we are ready to transform the transportation industry. We have the market demand. Heard from the folks that this is the biggest transformation since the invention of diesel engine for the logistic transportation industry. We have the proven technology. Our technology is proven to work in real commercial, real-world deployments. We have the distribution channels. We have secured these important OEM partnerships. We're moving the entire ecosystem forward. We have identified and been working with our core partners for years. And we have a highly scalable, capital-efficient business model to take this to the entire industry and globally. So we have all the pieces ready for us to become a really meaningful business and to make a major impact on the industry. So we're extremely excited about the future of our business. So thank you for coming here today and enjoying and share for us to have the opportunity to share our story with you. So next we'll have a Q&A session. You can ask any questions.
All right. Before we take questions, just a quick reminder, all of these slides are available on our website. And with that, we can start taking questions with David, Sean, and Steve. So we'll start with Walt, and then we'll go to other folks.
Thanks. I'm starting with Steve. I'll let him get settled in. On the unit economics, the other line, which didn't move, and I think there was some text next to it that said fuel efficiency, other things like that can bring that down. But on the flip side, if you're putting more miles per year, and obviously it's going to be a more expensive truck, wouldn't the lease also drive that up by a certain number of cents? And then also, is there any assumption in terms of like how many total miles they'd put on this truck? And so if I'm JB Hunt, I use let's say 1 million miles, they sell it in the secondary market. Are they getting residual value for that for a human driver? Or do you anticipate there's going to be a secondary market of like small fleet guys that you can still extend the licensing fee for them? Thanks.
Do you want to
take that or?
Okay. Yeah. So the question was basically around how many miles per year are these trucks going to drive? What's the impact in terms of fuel efficiency, total miles, right? And then also the total miles. So these trucks are all designed for a 1 million mile design lifespan. That's what trucks are today, and that's the same goal for the autonomous trucks, is also have a similar design lifespan. Now, autonomous trucks will drive about 3 times as many miles per year because of the ability to basically utilize them around the clock, 7 days a week. All right, and so they can be driven for about 240,000 miles per year. All right, so that's a really substantial increase in terms of the utilization that people will get out of those trucks. Now, from a fuel economy perspective, I think that was on the chart there is another benefit, and that's because this technology...
Wouldn't that increase the lease cost? If I'm putting more miles per year, then my lease cost per mile is this big tendence. Should that drive up as an offset to any fuel efficiencies you have?
Mm-hmm. Plus the truck itself is more expensive. So I think, just repeat in case people can't hear you. So the question was, will that then change the lease cost? So I would say that will depend basically on the OEMs as they then price that truck to their partners. Now I think that when you think about the maintenance and operation of these, it's going to be much more of a proactive maintenance, right? And have a firm understanding of that. And so that's part of what goes into needing to design the autonomous truck to last that type of lifespan. Now, the fuel economy actually is an added benefit. While it's not quantified in the slides there, it does bring additional benefit because with this technology, you can basically drive more efficiently than the most efficient human driver. Right? If you look at the fuel efficiency of human drivers, there's actually a pretty broad spectrum of fuel efficiency that people get. And this technology can basically outperform on the high end there. And given that fuel is such a substantial part of the cost, basically the next largest cost after the driver, this brings additional benefit there, right? The reason why I think that's not fully quantified in there is just because when you think about the total value pie here, so much of it comes from basically just taking the labor savings out, right? And then being able to increase the utilization so much, right? But yeah, there's these added benefits in terms of the fuel savings. There are also added benefits, because of the safety component of this, that you should start to see benefits in terms of insurance and other things, right? So those are all added things that come into play in terms of driving down the cost.
After 1 million miles, is there a secondary market or additional license fee, or are you just doing huge?
So I think the traditional lifespan of a truck is 1 million miles, right? So we don't plan to, in terms of having the autonomous operation beyond that, right? So I don't know how much that will, as you see the payback here, right, in terms of it increases the profitability per truck for these fleets by about 4.5 times. So we think that most of that is captured there. And I can't speak any further to basically a terminal value at that point.
I hate to do it again, but I might have to track Tobias. But how much of a markup do you expect in autonomous trucks versus traditional trucks? That's my first question. I know you haven't priced them yet, but and the second one is about network operations. I mean, robotaxis have famously robust network operations behind the scenes, helping to navigate the Waymos and robotaxis of the world. Why is your operation much more lean than that? I mean, I think I probably know the answer to that. I'm curious as to what your perspective is. So,
all right, let's get the questions of the Plus guys and not let Tobias to sort of talk about economics here.
I can answer the second one though, if you like. So the question there was just in terms of, from an operations perspective, what gives us confidence in terms of ability to offer that operationally? And there are a couple of things there. So one is TRATON actually has experience operating autonomous vehicles already. They already operate autonomous mining vehicles where they provide the remote oversight and support for those vehicles today. And so as they bring that to this market, in terms of the on-road hub-to-hub, it ties in very nicely in terms of how they do service support and everything for their customers today. And I think a key differentiator in this market as compared to, say the robotaxi market, is in trucking, there's already like a really strong and established operations and maintenance infrastructure that goes with all of the customer sites. These are also fixed routes that the trucks are driving, so it's known kind of where they're going to be. And there's a very strong, given that the importance of safety in this market, right? There are already very strong established processes and procedures for pre-trip inspections and post-trip inspections and so on for trucks, even human-driven trucks. And so now with autonomous trucks, you have these enhanced pre-trip inspections that cover that, right? And so all of those things tie into why the service support model for autonomous trucks is different, I think, than robotaxis, and why we're confident in terms of our partners' ability to do that.
Hey, it's Ken Hexter. So just I want to understand a couple things, David or Steve or Sean. But so you've got, who's taking the insurance risk here? Seems like billing and receivables are now put on the OEM since they're collecting the whole bill. So now they've got to build up a whole collection department versus paying the software provider. So I just want to understand that process. And so if you go 3 times the efficiency of the truck, are we now having dock workers working around the clock? I mean, I just want to make sure we're not estimating kind of how much a truck can pull up to a dock and have somebody there to keep that truck flowing, right? And then remote access, sorry, technical question, but does that mean somebody can hack it if now you can have remote access?
Those
are a couple of different.
Yeah, no, those are all great questions. So let me make sure, see if I can answer them all in turn. So on the first one, in terms of insurance, it's important to know in trucking today, most fleets are self-insured, right, given the nature of the business and the scale of the operation, right? So there already is structures in place in terms of dealing with how you handle the liability between the different parties, right? And so when you bring autonomous trucks into the mix, right, it actually fits. It's another reason why this fits into the existing value chain of the relationships between us as a technology supplier to the OEMs dealing with their customers, and then the management of how you deal with liability and issues between the fleets and OEMs. On the second question then was on, sorry. The dock workers, right? Dock workers, yes. So, excellent. So in terms of how these trucks integrate into operations then at customer depots, it's typically more in a drop and hook mode, right? Where there's just kind of the more efficient mode that many of the fleets move to, right? Which is where you have trucks come in and drop the trailers, pick up another trailer, go, right? And then you have workers that are then moving trailers back and forth. So many of those types of operations are already in operation 24/7, right? Freight moves nonstop in this country. And so this is really about just enabling the trucks to operate at a really high level of utilization, is they're able to basically continually moving when they're not in sort of maintenance or other things. And I'm sorry, what was the third one?
Question about hacking.
Oh, hacking. Yes, sorry. That's another great point. So Tim talked a lot about our approach to remote assistance and how we don't believe that the remote assistance should not be able to physically drive the truck, right? This is really more about basically reviewing and vetting potential trajectories, right, when the truck is putting this forward as candidates. So from a technology design standpoint, we've designed it such that the truck itself should be a stable, isolated entity, right, where you can't have remote operators tap in and try and drive the truck. Effectively, all that cybersecurity is a subset of the overall safety problem, right? It's basically safety when you have a sort of adversarial party that's trying to make it do something unsafe, right? So that is all tied in as part of our safety case and how we've designed the system to work.
Great. So, on the two metrics you've been publishing, the safety case and I think the remote free driving, is it too simplistic to say that the safety case metric improves with just basically more manual testing of the system, and the other one's more about the technology improving throughout the year, or what really drives those two?
So the safety case is driven by a lot more than just sort of manual driving and experience. It comes from a lot. There's a lot of things that go into that, right? So it's because it's a all-encompassing safety case that's structured across a lot of different dimensions. So it includes a wide variety of things, including a lot of the safety certifications we got last year in terms of, so those are both around process and sort of some of the designs. Comes from like deeply structured safety analyses of sort of how things work and different failure modes and failovers and so on. Comes from different discrete testing of those, right? When we talked about some of the structured testing we do in terms of testing of the truck with nobody in it, it comes from those sorts of things. It comes from performance of certain subsystems, right? It's a long list, right? It breaks down into literally thousands of things, right, that we're in process in terms of completing that goes into that, because it's a comprehensive safety case to prove readiness on those routes. So versus the RAF metric, as you can think of, is more as a top-level performance metric. So, as I mentioned, it doesn't need to get to 100% because the design is to always have remote assistance available, but you want to get that to a high degree of performance. And so that comes from basically the integrated testing of the system on these routes, right? And it shows basically what is the fully integrated performance of how often you're able to operate without any remote assistance.
So a simple way to think of these two metrics is safety case readiness, prove out the truck will not get into an accident. The RAF metric is more about ODD coverage, operating design domain coverage. Right? So for instance, what are the situations we get into, like calling a remote assistant? There's a road closure, right, or road construction work. That our truck will detect this to be a out of ODD situation. It'll navigate itself into a safe situation, like park on the side of the road, and waiting for remote assistant to give decisions, to provide decisions, right? And if we expand our ODD to take care of that particular situation, that particular road construction situation, then the truck can be autonomously driven through the construction zone. It will not call the remote assistant. So with the broadening of our ODD, with better technology, right, with better, more data, then we'll improve our RAF metric. So eventually, if we cover all of the ODD out there, that metric will be approaching 100%.
Hey guys, it's Mike Schlisky again. This is maybe for Steve. I couldn't tell in your presentation, I think the right-hand column of the opportunity chart where you mentioned you can drive 3 times the number of miles. I couldn't tell if there was also a component of it where you can use a lower cost truck. I mean, it kind of dawned on me that you could probably do with a day cab, go 1,000 miles without having to have a sleeper cab. So you would need that, I'm sure you can agree with me, Tobias, there. You would need to have a sleeper cab. Could you do this without as robust of a passenger of a cab? Do you even need a cab? Could you do it without one seat? Could you do it with a different fuel tank, etc.? I wasn't sure if that was part of it. Is that a big opportunity as well? And again, this is not for Tobias, but could you anticipate a different model being launched rather than the LT, or are you just going to put this on the LT to have that to have that resale value layer to a non-autonomous customer. Just what's the hardware story here?
So that's, I think that's an excellent question. Somebody put that back in terms of saying, in the long run, couldn't the truck look very different than it looks today to be more cost optimized, right? And I think the answer is yes, in the long run, it could. I guess we think about this a little bit similar to, I guess, the question we got earlier in terms of terminal value of the truck at 1 million miles, right? There are things that could be done in the future, of course, to make this even more profitable and even more economic, right? But it's not necessary to get it launched and first get it out there. So when you think about the amount of work that goes into integrating this technology into a truck to enable it to operate autonomously, it's quite significant, right? That's why it takes this time to get it all out there. And so that's not necessary to do the full redesign, as you just described, right? To have an even more optimized truck. So I think there is potential for those sorts of things as you look further down the road, right? Which is why, there are many things that we talk about today where we focus on really there's tremendous initial value to be captured here, but we haven't even put in basically all the second and third order effects of things to come, right? In terms of future cab optimization, in terms of some of the other sources of savings of insurance and so on, right? So there's a lot more to come in the future, but both to keep it simple and keep it focused on what we think is essential at the point of launch, we haven't yet accounted for those. But you're absolutely right. That is a big opportunity as you look further and further down the road here.
Mike Ward, what does the 85 cents per mile pay for, other than the software?
So think of this. So by the way, all these numbers we show are illustrative.
Yeah.
Right. There's an important footnote there. Right. Right. So the 85 cents is illustrated. It comes from the point where the labor cost today in the transportation industry is about 97 cents per mile. We think, between the OEM, so that 97 cents is captured from a value capture point of view for the entire ecosystem, right? Across the fleets, the OEMs, as well as PlusAI, the technology enabler, right? We think fleets will be able to capture, up to 12 cents or, around that of that 97 cents saving, right? So the remaining of the 85 cents will be provided to whoever provides that driver service, right? In terms of a virtual driver, it'll be provided at a better performance and lower cost. Rather than 97 cents, whoever provides the virtual driver service will be able to capture 85 cents for every month of driving.
I understand the savings, but if I'm a fleet, why would I pay the 85 cents? What am I paying for?
Yeah. It's paying for everything that your manual driver, human driver is doing.
But is there hardware? Who owns the hardware that enables the truck to drive autonomously?
The fleets will be buying that truck.
Okay, so back to the
buying or
question.
leasing that truck. Yeah.
Why the 85 cents? What is it paying for?
Well, so if you think about from a fleet point of view, right? Today they buy the truck, right? And then they pay 97 cents to the human driver for driver, right? So in the autonomous world, they're paying the 85 cents for the virtual driver.
Yeah, I mean maybe making a traditional system where you buy it, go and upward it back. So the driver gets hurt. Right. SaaS software cert is we're going to keep proving.
Okay, but it doesn't all go to you. We're just getting the 25 cents or so. So the rest of it's going to the OEM.
Yes, the 85 cents really goes to the OEM.
And what is that paying?
Oh, that's paying for all the integrated truck, the services, the warranty. It's a service. It's a transportation service as a tool that the OEMs are providing to the fleet, right? So the OEMs not only selling the truck to the fleet, they're also providing the virtual driver to the fleet. They're providing the whole thing, a truck with a driver installed in it to the fleet. So the fleet should pay the OEMs, the truck, and the driver. It's a better driver. It's a driver that works 24/7 and more safely and at a lower cost And you can call the driver anytime you want. That's what OEMs providing to the fleets.
Hey guys. Maybe if I may. So I think you have a good point. As this market matures, of course, it will be a competitive. It will be a competitive market, and as a customer, eventually, I don't know, in 10 to 15 years, maybe you can have different software drivers on different hardware platforms, and it will be an element of competition as well. I know there is room to provide additional services to the fleets that we consider value-adding. These will absolutely need the preventive, proactive services and maintenance with all the diagnostics, with all the remote connectivity, and a superior services arrangement. We also know that we need to set up a monitoring the controls and to control operations, so there is additional cost to support that as well. That is, of course, something when this matures further that some of the large fleets would potentially take over by themselves. Then they take the cost and they will pay less per mile. I think this is a good illustration. It would be great if this plays out, but I don't know if it's that material, if that is 70 cents or 85 cents in the end. That will depend both about the value add and the competitive landscape at this point. I think for us as OEMs, and I think I speak for the industry, if we make this happen, it's obvious that there is so much value add, that there is value for both fleet OEMs and the software provider. Exactly how those cents will play out, there is I see a lot of business case. This is one of the more promising. Exactly how that gets distributed, I think that is to play out and will depend on the competitive landscape as well. We believe, though, together with Plus, that there is value in the fleet. Some have speculated that why do you need a fleet? If you think that the fleet only organized drivers, then you have not seen their operations. We think there is great value for the fleet. We also think the integration and bringing pre-integrated hardware and being that robust partner that we have been for a very long time to those customers have a strong value. But at the same time, we see that the niche software players in this industry have a very important role to play as well. So I feel fairly confident with that, both in terms of our partnership and for how the industry evolves overall.
Thank you, Tobias, for providing that answer, because he talks about what OEMs thinking about it more accurate than I kind of relay that message.
One question here.
Hey guys, Aaron Kimson from Citizens Bank. Thank you guys for doing this today. My software analyst brain is learning a lot. Given the industry structure here with the concentration of OEMs, why don't the OEMs build autonomous driving software themselves or buy you once you get to commercialization? Is there something different about the commercial trucking market where it doesn't make sense for the OEMs to verticalize up through the software layer, like Tesla's doing in consumer with FSD or Google's doing for rideshare with Waymo? Thank you.
I can provide my answer, but then feel free, Tobias. I think OEM. So first of all, absolutely, it is an important strategic area for every single large OEM to look at, and we've heard that from many of the conversation we have with OEMs. So there's no question about from a demand point of view, they need to make this happen. Now, from an execution point of view, OEMs is in the business of providing the best product, quality product to their customer, which is fleet, right? How do they execute on that? Every single OEM has a different strategy in doing that. Some of them decide to develop all of their technology in-house. Others decide to develop certain technology in-house and partner with the best of breed in adjacent industries, right? From a supplier point of view, right? Like not all OEM develop their own tires or engines, right? And many of them develop their own engine, but not everybody they develop their own steering. These components coming from technology suppliers to the OEMs. And in terms of autonomous driving, from a software point of view, many of OEMs decided that or realized that Silicon Valley-based AI company is better at it in creating this, call it AI native virtual driver. So they decided to partner with the best who can provide this technology to them. And in the case of TRATON and the Iveco and Hyundai commercial vehicles, they look at the entire field. They decided that from a technology point of view, from a culture fit point of view, from an alignment of our vision and strategy point of view, PlusAI is the best partner. That's why they decided to work with us to create this product for their customers.
Hey guys, Cole Cousins from Wolfe Research. Just quick question. So you're charging 85 cents per mile. That's less than a carrier. How flexible is that over time? And in theory, you're providing more value. So at some point, once you scale, couldn't you take more than that? And then also on the 85% gross margin, kind of how steady is that? What is driving that assumption? Is there some contract in place with the OEMs? And then maybe just on operating cost, how's like SG&A and R&D supposed to progress over the next 5-10 years?
So let me answer the first question, and then Steve, you feel free to add. So first of all, we do not capture 85 cents per mile. So let me first clarify that. We think we'll be able to capture, create 97 cents in terms of labor savings, and then between the provider of this autonomous driving technology in an integrated autonomous truck point of view, you'll be able to capture somewhere around 85 cents. But that's between the OEMs and fleets, right? We think we'll capture a slice of that economic value creation, between 20 to 25%, depending on the OEM, depending on what we do or what we provide for the OEMs, right? So that's in our commercial contract with the OEM. So our business model is is to be able to derive that software sort of SaaS revenue for every mile of operation of the product that OEMs going to deliver to their customers. Now, why is 85% a gross margin? Well, most of the SaaS software business run at that soft margin, right? We do not incur any CapEx in terms of delivering the autonomous truck to and making that autonomous truck, and we do not incur any OpEx operating the autonomous truck. So what's primarily, our cost is on core R&D and supporting the technology delivery to the OEM partners.
Yeah. And just to add to that, we're 75 to 80% R&D focused. So we're very, very, very R&D company. SG&A is there to support our operations and support our engineers, but it's very, very modest, as most software companies are. So you'll see increases in our SG&A, but at a very, very slow rate compared to the R&D. And as we shared before, even our costs over the next couple of years is modest on a year-over-year basis. So SG&A goes up, but at a very, very slow rate compared to R&D.
Okay, we have time for just a couple more questions because we promised to get you guys all out in time for earnings.
I had two quick questions. The first one is, when can you start naming your fleet partners? What do you think they need from you to feel comfortable putting their logos on a truck running the SuperDrive system? And then my second question is about your thoughts on Tesla and if you see them as a competitor in the autonomous trucking industry.
So first question, it's the fleet customers are not our customers. Well, they're our end customer. They are our OEM partners' customers. So it's really up to our OEM partners to decide on the timing of that announcement. But it's coming in the next couple of quarters. The second question about Tesla?
Do we see them as a competitor? I mean, I think, keep in mind the scale of the trucking market. Right? Most fleets today are operating conventional diesel trucks. That's really where all the volume is, and that's what's happening, right? And so in terms of how we view the market, right, the market is basically the landscape of OEMs that I showed earlier. Right? Those are the OEMs that are producing really substantial volume into this market today, and those are the OEMs that are looking to launch autonomous trucking products to the fleets today.
And let me add to that, we see Tesla being the tailwind, more of a tailwind for the autonomy industry than a competitor in the industry. I think they've done, the industry a great favor in terms of electrification, and I think they are, to the point that they can, continue to innovate in the autonomy segment. I think it'll be a tailwind for us as a company.
Yes. So, Steve, you mentioned you're very different in cost than others. So maybe just describe that, because others are selling the service, right? And then paying the manufacturer a fee, whereas you're now going through TRATON and others to be your sales force and sell the PlusAI technology. So one, maybe just delve into the cost there, because then that seems like the responsibility for any downtime or any problem becomes onto TRATON or the manufacturer, right? So if it's tires down or who's responsible for fueling the truck, whatever, it's not on you. You're the software behind the scenes. So then it becomes even more important for that relationship with the manufacturer to become the operator, which they're not today, right? So maybe talk a little bit about that.
Well, Albany, you should answer that.
Okay, I'm happy to speak to that. So uptime is a huge topic for all OEMs today, right? That's a big focus for OEM partners in terms of why they focus so much on both designing the trucks for high reliability, providing a high degree of service and support to go with the product, and maintaining a high degree of uptime, right? So when it comes to things like if there's an issue with the tire or other things, right? These are all things that the fleets are responsible for maintaining on the vehicles, and they work with the OEMs today, and they have those established networks to do that. So you can really think of this as an extension of how the industry value chain works today. Moving into, there are some additional technology components in terms of higher power computer and some additional sensors. But from a delivery standpoint, that's really how the industry operates today and how we foresee it to continue to operate in the future. And there's no need from a cost standpoint, as Steve talked about, for us to stand up our own independent delivery of those types of services, right? Because we're building on basically the value chain as it exists today.
It's the difference of being vertically integrated versus working within an ecosystem. So, competitors might choose to be vertically integrated, and for that, they would get a larger percent of the revenue, but they have 10 times the costs because they take on all the operations of the network. And for us, our DNA is just to be the software layer, working as that component in the ecosystem, working with our OEM partners, in this case, TRATON, to be able to divide and conquer who's delivering what of the value chain and taking that component from a profit margin from it. So for us, that works out best for us, being part of the ecosystem and being a horizontal, not be vertically integrated. And from a retrofit perspective, I mean, we believe very, very strongly to be successful, you need to be factory installed. That retrofits is not the way for scale, success, and profitability in the long term. So you can have multiple players with multiple models. This one speaks to us, to our strengths, and to our natural DNA as a partner with great organizations like TRATON and others.
Great. Thanks, everyone, for coming, and we look forward to having an ongoing dialogue.